So in this video, we are going to introduce solving one, two, and multi-step equations. When we're solving equations, the big thing with an equal sign is that you want your students to think of the equal sign as the pivot on a balance. So whatever we do to one side of the balance, we have to do to the other side of the balance. So since equations have an equal sign, it's easiest to picture them as a scale to remain balanced. If we put something over here, we must put it over here, and then same thing as taking things away. So we have a couple of properties of equality. The first property of equality is going to be addition and subtraction. And so the addition property of equality is going to say that for any real number a, b, and c, if a equals b, so we're starting there, then a plus c equals b plus c. What that says is I can add c, or some number, to both sides. And then the same is going to be true of subtraction, that if a equals b, then a minus c equals b minus c. So the same thing is true that I can subtract from both sides. It's only true if I do it to both sides. And so we have this kind of picture version of this scale. On the left, we're adding something to keep that balance. And then on the right, with subtraction, what we're actually doing is we're thinking about removing those things from both sides. And then that would keep that scale still balanced. Our second properties of equality are going to be multiplication and division. So with multiplication, the same is going to be true, that if a equals b, then a times c equals b times c. So again, what we did was we just multiplied both sides by c. The key is to multiply both sides. And then for division, if a equals b, then a divided by c equals b divided by c. Again, doing that thing to both sides. And then we've got this picture of the balance. If I multiply by a heart on the left, I have to multiply by a heart on the other side of the balance sign. Same thing with dividing on the right. So the big takeaway here is that addition and subtraction are inverse operations, and multiplication and division are inverse operations. So as we start moving into our study of solving equations, we're going to undo operations in order to isolate the variable. And what that just means is I want to get x, or whatever the variable is, by itself on one side. And so I'm going to use these two inverses. If I have addition, to undo it, I'm going to subtract from both sides. That's where that equality property comes into play. If I have multiplication, I'm going to use division on both sides. And so we have a couple of steps in your notes. The big thing with these steps are you can always check your answers. So before you turn your test in, before you turn your homework in, on these solving equations, you'll know, assuming that you did the math correctly when you back sub in, you'll know if you got the right answer. And so our our steps are going to be to handle the fractions first. There's a couple of ways to handle fractions. At our level, probably the easiest thing is just to continue to add or subtract, multiply or divide the fractions like you learned how to do in Math 211. But you can multiply through by the LCD, or if it's just one fraction, just multiply through by the reciprocal. The reciprocal means that you're going to flip the fraction upside down. So if it's 1/2, the reciprocal of that would be 2/1. Then you're going to handle your parentheses. To undo parentheses, you will use the distributive property, which just says if you have something on the outside of the parentheses, you are going to distribute and multiply to everything inside. So that would give you AB plus AC. And then you're going to combine all the like terms on the left, all the like terms on the right. And then if you have a variable on both sides, you're going to move the x's or the variables to one side. Typically, we want to undo the smaller variable just because it's going to avoid some negative numbers. And then if you have a constant, you're going to undo that constant, which is going to be addition or subtraction. And then if you have a coefficient, which is a number in front of the variable, if you have a number in front of the variable, then you're going to use multiplication and division to undo those. And so let's look at a couple of examples. And so we're going to do, there's another video with using virtual algebra tiles to solve these. We're going to solve algebraically, so solve using the steps above. So the first one I have is x plus 2 equals 7. Well, my goal is going to be to get x by itself. So to undo the plus 2, I'm going to minus 2. If I do it to the left side of my equal sign, I have to do it to the right side. So that equal sign is just going to fall down. On the left, the positive 2 and negative 2 cancel. That gives me 0. And I am left with x equals a positive 5. Now, you can check all of these, like I said earlier in this video. And to check these, you are just going to back sub. And so what that means is in my original equation, x plus 2 equals 7, I can take the 5 that I just found to be my answer, plug it in for x, and see if it does make the equation true. And 5 plus 2 is 7, and so I know I got that thing correct. Number 2, negative 5x plus 8 equals negative 7. So I'm going through those steps. Do I have fractions? No. Do I have parentheses? No. Do I have variable on both sides? No. Do I have like terms? No. Do I have a constant on the same side as the variable? Yes. And so I'm still trying to get x by itself. And to get x by itself, I have to get rid of the constant term first, the positive 8. I'm going to subtract 8 from both sides. Those 8's, positive 8 and negative 8 is going to cancel, which is going to leave me with negative 5x on the left. And then on the right, I have negative 7 plus negative 8 is going to give me negative 15. That was my first step. Second step says I'm still trying to get x by itself. Well, now I have negative 5 times x. If you don't see an operation, that's implied multiplication. So negative 5 times x. So to undo times, I'm going to divide both sides by negative 5. Those 5's will cancel because that's really just 1x, and I don't need to write the 1. And so then I'm left with x equals negative 15 divided by negative 5 is going to give me positive 3. Again, I can check these by plugging in my answer into the original equation. So where there was an x, I'm going to replace with a 3. I've got negative 5 times 3 plus 8. Does that equal negative 7? Well, negative 5 times 3 gives me negative 15, plus 8 does give me negative 7. So I know I got that thing correct. All right, my next one, number 3. 8 equals n plus 5. They flipped it around on me. They put the n on the other side of the variable on the other side of the equation, but that's okay. I'm still trying to get that variable by itself. And so I need to undo plus 5. So I'm going to subtract 5 from both sides, carry down that equal sign. Those 5's are going to cancel and leave me with n equals positive 3. Or we could write that as n equals 3. Either one of those are correct. If you choose to, you could rewrite this way back at the beginning and flip that order around. We have a property that says you can flip the order over the equal sign and not change the value of that. And then I could continue to solve from there as you are teaching this to your students. Now remember, I could check these. This will be the last one we check. But I could check these by saying 8 equals n plus 5. Well, n I just found was 3. And so is it true that 8 equals 3 plus 5? Yes, 8 does equal 8. And so I know I got it correct. Another way that you can introduce equations the first time without even introducing variables, and this is just something that you'll see in your classroom one day maybe, is just use a shape. So what this says is what number plus 5 gives me 8. Well, that makes it a lot easier for your students because they can just think backwards and see, well, 3 plus 5 would give me 8. And then they've just solved an equation. And then you'd start to replace the pictures with letters and kind of progress them into the solving algebra. So 4x plus 2 equals 26. We're going to go through this one and solve it algebraically. So I'm going through my list of questions. Do I have fractions? No. Do I have parentheses? No. And I'm going all the way down until I get to the one that says, do I have a constant on the same side as the variable? Yes, I have a 2. And so I want to undo the 2. So I'm going to minus 2 from both sides. Those will cancel and leave me with just 4x equals 24. Now 4 times x, to get rid of that, I'm going to divide both sides by 4, carry down that equal sign. The 4's are going to cancel and leave me with x equals 6 as my final answer. You could check that. I will not in the video, but you would check that by plugging in the x equals 6 right there where there was an x in the original problem. All right, my next one is a little bit more complicated. So do I have fractions? Still no, but do I have parentheses? Yes. And so with these parentheses, what I want to do first is I want to distribute the numbers out front. And so 4 times x is going to give me 4x. And then 4 times 3 is going to give me 12. I'm going to do the same thing with 5. 5 times x is going to give me 5x. And 5 times 3 is going to give me 15. And then that equals 99. Now the next step says, do you have like terms on the left or like terms on the right? And I do in this problem. I've got a 4x and a 5x, which is going to give me 9x. And then I've also got 12 and 15, which is going to give me 27 equals 99. Now the problem looks very similar to what I've been solving. I'm going to subtract 27 from both sides. My 27s are going to cancel, and that's going to leave me with 9x equals 72. Divide by 9, divide by 9. My 9's are going to cancel and leave me with x equals 8. Now, if you were going to check this, you would plug back into the original equation all the way back at the top. You would plug in 8 everywhere that there was an x. And so you would replace that with an 8 and that with an 8. And then you could do the parentheses first and then multiply by that, add them together, and you should get out 99. Now in your notes, it says to complete the following problems in place of number 2 in your textbook. You can ignore those. I have problems in my lab for you to do. They are not the greatest. I would recommend practicing these for the test. So these are going to be like the problems you'll see on the test. They will not be quite like you will see in my lab. So you don't have to do this homework. This is just optional, but there will be similar questions on the test review, and then you can also use these to check just to do a couple more examples.